Hello students, welcome to all English medium revision class. Today we are going to discuss about probability. Probability is possibility of an event. The sample space of a random experiment to be discussed today. In this lesson, we are going to discuss following learning outcomes. By studying this lesson, you will able to solve problems involving the events of a random experiment occurring in two stages using a grid, Cartesian plane. You know about a Cartesian plane. Then a tree diagram. These are the diagrams we are going to use when representing the sample space graphically. We will see probability of an event. How to define the probability of an event? Right? In an experiment, the set containing total outcomes is defined as the sample space. Using the sample space, we can define an event. In that case, we want to find out the possibility of occurring that event. You can see the definition. Considering an event A, the probability of A is defined as PA. Probability of A is PA. Then PA is equal to number of elements in the event. Number of elements in the event divided by number of elements in the sample space. This is how we find the probability of A. Remember that A is an event. PA is defined as NA over NS. NA, number of elements in set A, is divided by number of elements in the sample space. This is the theoretical definition of the probability of event A. If you put here PB, probability of B, how to define? Number of elements in the event B should be divided by number of elements in the sample space. There is a pattern. PA-NA. NS is compulsory. Right? If you consider PB, NB, PC, NC, there is a pattern. You have to identify that. Right? We will see. Mutually exclusive events. Before learning about mutually exclusive events, you have simple events. Simple events. Simple events. Event containing only one element. Think about tossing a coin, getting head. This is a simple event. Getting tail. Simple event. Right? Then compound events. Compound events. Right? Compound events like that. Compound events. Getting head and tail. You can divide this compound event into simple events. Right? Now we are going to discuss about mutually exclusive events. We will see the definition of mutually exclusive events. if capital A and B are mutually exclusive events, then there is a condition. What is the condition? A intersection B is a null set, no elements in that set. Therefore, number of elements of A and B is 0. Now, the theoretical definition of the probability PA intersection B equals NA intersection B over NS. Can you remember the pattern? Here, if you have PA, NA over NS, right? If you have Px, how to define it? Nx over Ns. If you have Py, how to define? Ny over Ns. Likewise here, PA intersection B is equal to NA intersection B over Ns. 0 over Ns is equal to 0. Therefore, probability of A and B is equal to 0. Now you got the result. If capital A and B are mutually exclusive events, then PA intersection B goes to 0. Right? This relation is very, very important when solving problems based on probability. Right. Conversely, if probability of x intersection y is equal to 0, then x and y are mutually exclusive events. Right? This is the opposite situation of this one. If capital A and B are mutually exclusive, then Px intersection y goes to 0. Conversely, if Px intersection y is equal to 0, you know that x and y are mutually exclusive events. Right. Independent events. We'll see what is the definition based on independent events. There are two events here, A and B. If A and B are independent events, then PA intersection B is equal to PA dot PB dot means multiplication. Probability of A should be multiplied by probability of B. Right? This is the compulsory condition of A intersection B when A and B are independent events. Right. Conversely, there is a converse case here. Conversely, if Px intersection y is equal to Px dot Py, then we can say x and y are called independent events. Right? This is our opposite situation of first relation. Right? Remember, this is very, very important when solving problems. Next one, there's a practice problem. We can practice the concept we learned. PA intersection B is equal to 1 over 6. PA, probability of A is half. Probability of B, PB equals 1/3. Now you can see PA dot PB half multiplied by 1/3, multiplying a fraction by another fraction, then 1 over 6. Secondly, PA intersection B equals 1 over 6. Now, the first relation is equal to the second relation. It means our definition, since equation number 1 is equal to equation number 2, PA intersection B is equal to PA dot PB. Then capital A and B are independent events. That is how we identify independent events, right? Now, probability of two events. In this case, we are going to discuss about probability of two events. You have to consider two events. We'll consider two events as capital A and capital B. Capital A and capital B. We want to find out the probability of occurring AOB. 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 We know that O union and intersection. Now, probability of two events. Consider two events capital AB. Probability of events occurring AOB. AOB is defined as PA union B equals PA plus PB minus PA intersection B. We'll name this as our first equation, right? This is the probability of two events. Then you can change event as X union Y. Px union Y is equal to Px plus Py minus Px intersection Y. Identify the pattern. There is a pattern in every maths concept. There are so many concepts in mathematics. There is a pattern. That pattern is called the definition. If you can identify the pattern or if you can understand the definition, then it is very, very easy. Right? Now we will see when capital A and B are mutually exclusive events, there is a condition. Can you remember? There is a condition. What is that? PA union B is equal to PA plus PB. What has happened there? PA intersection B goes to 0. Here there is a remaining part. PA intersection B. This part goes to 0. As a result of that, you have PA union B is equal to PA plus PB. Then, when capital A and B are independent events, then we can rearrange our first relation as PA union B equals PA plus PB minus PA multiplied by PB. Because of the condition, PA intersection B is equal to PA dot PB. Right? Now, we can see some different applications of these concepts. Now, we are going to discuss past paper questions and you can develop your competency level based on probability after studying the concepts and the applications based on probability. Right, 2016 paper 1 part B structured question. Question number 4. There are 3 red tennis balls. There are 3 number of elements in the event. There are 3 red tennis balls and 1 green tennis ball. Number of elements in the event. A ball is drawn from the box, its color is recorded and is put back. Is put back means with replacing, doesn't change. the elements of the sample space. A ball is drawn from the box again and its color is also recorded. The balls are drawn randomly. Random experiments. Random experiment. This is a random experiment. Right? You know what are the properties of a random experiment. Okay, we can see indicate the relevant sample space, total outcomes of the random experiment. Sample space in the given grid. Grid is a Cartesian plane. There are two perpendicular axes like this. First stage here, first one, first stage, second stage. Cartesian plane. You can represent an event like this. This is the event. We'll see how to do it. Indicate the relevant sample space in the given grid using the mark cross. R1, R2, R3 represent red balls and G represents the green ball. Indicate the event of drawing the green ball at least once. It is very, very important. Word condition. There is a condition. At least once. It means more than one. At least one means more than one. More than one. Including 1, 1, 2, 3, 4, 5 like that. Right? By encircling, it means as a closed plane figure, you have to indicate the relevant event. Right, we'll see it. And write down the probability. Write down the probability. Probability is a fraction, a number, another number. Probability. Here you know number of elements in the sample space. Here you can put number of elements in the corresponding event. Here this is the grid. First drawn, second drawn. We'll see. This is an event. In first drawn, first red ball. In second drawn, first red ball. With replacing. This is the probability of getting a green ball at least once. At least once. Here, green, red 2, green, red 3, green, green. According to the condition, this is the enclosed region. How many elements in the event? 1, 2, 3, 4, 5, 6, 7. Number of elements in the event should be divided by number of elements of the sample space. That is the probability of this event. 7/16. 7/16 is the corresponding probability according to the given question. Right. Now, 2 of the 3 red balls are each marked with the letter X, and the remaining red ball and the green ball are each marked with the letter Y. Suppose that the letter marked on the ball was also recorded in each of the above drawings. Now there are 2 sets, X, right? X, letter X. We'll see in the diagram. Complete the following tree diagram relevant to this random experiment. Here first row and the second row. Okay. Here the probability of y is half. Sum of these two probabilities should be 1. Here you have half, here also you must half. Half plus half is 1. We will see. This is the probability of getting x. This is the probability of getting x. Right. Then how to write the sample space using this one? X comma x. Here x comma y. Here y comma x. Here y comma y. Now how to get the corresponding probability? Half multiplied by half, it means 1 over 4. Here half multiplied by half. Here also 1 over 4, right? Similarly 1 over 4, 1 over 4. Right, we will see it. Find the probability of drawing balls marked with the same letter on both occasions. Same letter, x x or y y, right? Same letter, x x or y y. X x means you know half into half, 1/4 plus 1/4. 2 over 4 or half is the probability, right? You understood well. Then state with reasons whether there is a greater probability. Greater probability. Probability is a fraction. You have to find out the greater fraction. Comparison of fractions. Greater probability of drawing balls marked with the same letter on both occasions. Same letter on both occasions. Same letter. What is the probability there? Probability is half. Or drawing the green ball at least once. Can you remember? That was 7 over 16. 7 over 16. Now what is your greater fraction? You have to make the denominator as 16 using the knowledge of equivalent fractions. You know that this is 8 over 16, this is 8 over 16, here 7 over 16. It is clear that 8 over 16 is the greater fraction. It means half greater than to 7 over 16. We will see. Right. This is the answer. Okay. Read the question well. Identify the given conditions. Then you can use your previous knowledge to complete the answer. Right. Comparison of fractions. Then 2017 O-Level Maths Paper 1 Part B Structured Question, question number 5. A box contains 5 bulbs, which are identical in shape and size. Of these, 2 burnt out. This is our first event. Bulbs, and the rest means remainder. 5 minus 2, 3, right? Rest means 3 are good bulbs. There are two events, burnt and good. Then you have to find out the number of elements belongs to burnt and good. Experiment is based on elements. Probability is based on what? Elements. Okay. A bulb is drawn randomly from the box and examined. Using the symbol X represent the sample space of the experiment of drawing bulbs in the given grid. The burnt out bulbs are denoted by B1 and B2 and good bulbs are denoted by G1, G2 and G3. In the grid encircle, it means a closed plane figure you have to make. The event of drawing at least, again also at least one burnt out bulb and find its probability. In previous problem also, at least condition, very very important word, at least. We will see. This is the grid, empty grid. Now you can see the sample space first drawn. This is the sample space of second drawn. Right. Burnt out. Then without replacing, you can see the sample space. No elements in this diagonal. Then how to get the number of elements of the sample space? N multiplied by n minus 1, number of elements. Here you can see 1, 2, 3, 4, 5. Therefore, number of elements of the sample space 5 multiplied by 4, that is 20. Experiments without replacing, right? If you have events in these positions, then how to get it? Ns is equal to n into n. It means here you can see 5 multiplied by Ns equals n into n. It means 5 multiplied by 5, this is 25. Experiments with replacement, with replacement, without replacement. Now, at least one burnt bulb, at least one burnt bulb. Here letter B. What is the probability? Number of elements in the closed plane figure 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 over 20. It means 7 over 10. Now, an incomplete tree diagram relevant to the above experiment is given below. Complete the tree diagram by indicating the corresponding probabilities. A burnt out bulb is denoted by B and a good bulb is denoted by G, right? Events are represented as capital English letters, right? First row, second row. Then how to write the sample space? G, G. Here G, B. Here B, G. Here you have B, B. Sample space. Then you can write the corresponding probabilities. Multiply 3 over 5 by this probability, then you have the probability of this event. We will see it. 3 over 5 without replacing. Without replacing, it means in first row you have 3. In second row 3 minus 1 2. What will happen to total number of bulbs? 5 minus 1 also there. Therefore, 2 over 4. Right. We will see using the tree diagram, find the probability of exactly one of the 2 bulbs that drawn in the experiment is burned out. Exactly one. Not at least condition. Not at least condition here. Right? Then exactly one. It means only one. Here they ask find the probability of exactly one of the 2 bulbs that drawn in this experiment is burnt out. It means compulsory letter B there. Only one letter, right, in the event. They ask about the sum of these 2 probabilities. Now using the tree diagram, 3 over 5 multiplied by 2 over 4. This is the B, G, B, G, B, G. Right? We consider the sum of probabilities of these 2 events. 3 over 5 multiplied by 2 over 4. Finally, you have 6 over 20. Here 2 over 5 multiplied by 3 over 4, 6 over 20. Then 12 over 20, or using your knowledge of equivalent fraction, simplest form of this fraction is 3 over 5. Now 2018 past paper question. Paper 1, part B, structured 1, question number 4. A bag contains 3 vanilla flavored milk packets and 2 chocolate flavored milk packets of the same size. After Kamala takes out a milk packet randomly, Nimala also takes out a milk packet randomly. This is the experiment. This is the experiment. Right? Now we can see the sample space of this experiment. Using the symbol X or cross mark, represent the sample space of the above experiment in the given grid. The vanilla flavored milk packets are denoted by vanilla 1, vanilla 2, vanilla 3, V1, V2, V3, and the chocolate flavored milk packets are denoted by chocolate 1, chocolate 2, it means C1, C2. In the grid, encircle, always remember, a closed plane figure needed. The event of both of them taking out vanilla flavored milk packets and find its probability. Try to understand the question. Encircle the event of both of them taking out vanilla flavored milk packets. Vanilla flavored milk packets. This is the given condition of the event, and find its probability. This is the grid. Then you can see the sample space without replacing. Number of elements in the sample space here 1, 2, 3, 4, 5. 5 multiplied by 4, 20. Number of elements in the sample space is 20. Then you can define the probability out of 20. It means 20 is in the denominator. Right. Now this is the event under the given conditions. In both occasions, V1 V2, here V1 V3, V2 V1, V2 V3, V3 V1, V3 V2. Only V, it means vanilla, only vanilla flavored milk packets, right. Then what is the probability? Number of elements based on the event 6 over 20, it means after simplifying you can see the simplest form of the fraction as 3 over 10, right. Now, the probability of a certain sports team winning the first game they participate in is 3 over 5. If they win the first game, then the probability of them winning the second game is 7 over 10. If they lose the first game, then the probability of the winning second game is half. An incomplete tree diagram drawn to represent this information is shown in the figure. We will see it. Complete the tree diagram by indicating the relevant probabilities. First game 3 over 5, winning the game, losing the game. What should be there? 2 over 5, right. Here we will see 3 over 5, losing the game 2 over 5. Here winning 7 over 10, lose 3 over 10. Next one, half half, no conditions. Lose the game, half the probability of winning second game. Here the losing, it means that is also half. Always you can see the sum of probabilities of these two events is equal to 1, right. That is the important concept. Then how to make the sample space? Win-win, here win, lose, here lose, win, here lose, lose. This is the sample space, right. Now find the probability of the team winning at least one game, at least one. Find the probability of the team winning at least one. It means 1 minus probability of lose, lose, no, right. Okay, we will see. Here we consider 3 branches, 3 over 5 multiplied by 7 over 10 plus 3 over 5 multiplied by 3 over 10 plus 2 over 5 multiplied by half. Then you have 21 over 50 plus 9 over 50 plus 2 over 10. It means 40 over 50 or 4 over 5. How did you get this one? Like this. Try to understand. Win, lose. Win, lose, WL, we will see WL, here WL. Right. At least one game, winning at least one. It means this probability WW, here W, L, here LW, here LL. Without considering this event, we considered all these probabilities. That is what you can see here. Both are correct. Complement of an event, remember it. If you consider two events like this, probability of x plus probability of complement of x is equal to 1. Using that relation also you can consider the probability of the team winning at least one game. Okay. Now 2019 past paper question, part B, question number 4. We will see the experiment. It is given that the first two symbols of a certain password, in this password, first two symbols, there are two symbols, are two different digits of the digits 1, 2, 3, 4, 5, different digits. To choose the first digit of the password, a student randomly picks a card from 5 identical cards, on each of which one of these digits is written. Then without replacing, there is a change of elements in the sample space in second case. He randomly picks another card to choose the second digit. We will see this experiment, how to represent graphically. Using the symbol cross mark, the sample space of the two digits on the cards that the student randomly picks on the given grid, right? Now, next question. It was later discovered that the first digit which was obtained for the password was odd, and that this digit was less than the second digit that was obtained. Indicate the event that satisfies these conditions on the sample space and obtain its probability. What is the condition there? There is a condition. Large text. You get the essential word there. What is that? For the password was odd and that digit was less than. That digit was less than the second digit. Odd. You know about odd numbers, 1, 3, 5. Odd, right? Odd and less than second digit. Therefore, first digit should be less than to second digit. Try to identify the concept. Okay. This is the grid. Now, this is the sample space. Different digits, no same digit, right? Okay, this is the event according to the given condition. Odd one. Can you remember? First digit odd. 2. Here 1, 3. 1, 3. 1, 4. 1, 5. So on. Now try to identify the number of elements according to the given case, right? There are two conditions here. First one is odd. Second number should be a larger number. It means first number is the smaller number. Second number is the larger one. Smaller odd, larger number. Smaller odd, larger number. Understood it? Here 1, 2, 1, 3, 1, 4, 1, 5. Here you can see 3, 4, 3, 5. You can't consider 3, 1 here. 3 is an odd number, but you can't consider. Why is that? You can't consider because the second number is a less number, smaller number, right? Now, we can see the corresponding probability. Number of elements in the event 6. Number of elements in the sample space is 6. Therefore, 6 over 20. the probability 3/10. Now, during a period when a certain disease was spreading, 20 males and 16 females who displayed the symptoms of this disease to arrived to obtain medication from a physician. Although all the females actually had, all the females means probability is 1. All the females, probability is 1. All, right? 6/6, 20/20, 30/30, likewise. All females actually had the disease. The probability of a person picked at random from among the males actually having the disease was 0.6. 0.6 means 6/10 as a fraction, right? Now, complete the tree diagram by indicating all the relevant probabilities. Male, female probability, right? 20/36, 16/36. Male, female probability. Now you have 20 plus 16, 36, right? Having the disease, not having the disease. Having the disease is 0.6, not having the disease is 0.4. Here all the females, it means 1, probability of this part is 1. Then how to do it? Now we want to find out the probability under 2 cases. We want to find out the probability under 2 cases. You can see there are 2 cases here. According to those cases, we want to calculate the probability. Right. Find the probability of a person picked at random being a person having the disease. Person means males, females, right? 20/36 being a male multiplied by 0.6. Here being a female, 16/36. Here you have to multiply this fraction by the probability, like 0.6. All the females had the disease, it means probability is 1. 16 multiplied by 1 is 16/36. Here 12/36 plus 16/36. After simplifying, 28/36 or 7/9. Right. This is the end of the lesson. Today we discussed about probability. Probability is based on sample space of an experiment. We discussed the graphical representation of a sample space using a grid and a tree diagram. Then you know how to identify an event in the grid and how to identify the probability in a tree diagram. In your O-level examination, there are 2 essay type questions based on the theme sets and probability. First question is in your paper 1 part B, structured 1, probability. The second question is essay type 1, second paper, sometimes question number 12 or 11. 20 marks you can earn from this lesson, sets and probability. Okay. Now we are going to stop the lesson. We'll meet again with a new lesson next time. Get ready. We hope to see you with a new lesson. Goodbye to all.